Hello, everybody. So, in chapter 4, section 1, part 4, we're talking about polarization. So, what is exactly polarization? Well, in this case, we're talking about an object, for example. An object, let's talk about a simple circle, is made up of very small molecules, right? So, we're going to have, for example, a molecule here, a molecule here, a molecule here. Actually, I'm just drawing a few of them. Of course, there's almost infinite of them all around. It's not just the ones that I'm drawing, but I'm just making it a little bit easier. Anyway, so what can we do with this? Oh, let me just go right now. Well, actually, when we apply an electric field on the outside, the molecule on the inside are affected as well. What does it mean? Well, it means that if you decide if this field affects the molecule inside, the molecule side will actually be start pointing in the same direction. So in this case, we would have a positive side on this side and a negative side on this side. And here, this would happen all over the uh, this would happen all over the uh, object. Now I'm drawing big molecules just to make sure that you can see the polarization that is happening. But actually, this molecule will be very small. Of course, they're the same size. It's just that now they are polarized. So as you can see, they become polarized, and they themselves create another uh, electric field, therefore pushing like another field in the same direction because now they're polarized, right? So this vector field affects this um, molecule on the inside, and of course, molecules that I just draw a single. This is the atom, and then we have the electrons rotating around. Okay, now this atom is just minding on the business chilling, but when it's polarized, then the electron, for example, move towards this side, and the charge is going to be the positive charge, which is the inside, is going to be towards the right. So now this is the positive, and we can imagine as a center for these all these negative charges to be here. Sorry. So now, as you can see, we are polarized, but here it's like having a magnet. We would have an electric field, something like this actually, a dipole moment. And that's what it's the problem is. So what this section is talking about, and of course, it's saying um, how the section 4.3 in our case, it's gonna put together all that we have seen. So it's gonna put together the force, the electric field that is responsible for this dipole moment, and then what electric field is caused by this dipole moment.